Okay, let's consider the ratio test. Okay, we get, so this -1 to the power of n minus 1 will not have an impact in the absolute, inside the absolute value. So we have just x to the power of n plus 1, n plus 1, 5 to the power of n plus 1, times by the reciprocal. Okay, which is the same as, so this is a n plus 1 and this is a n. Okay, so let's simplify this. If you do n plus 1 minus n, we just get x. N times, you get n times n over n plus 1. And then if you reduce that, you just get 1 over 5. Now this is going to equal to 1 over 5x as n approaches to infinity. Okay, so that has to be true. In other words, the absolute value of x has to be less than 5 to be convergent, which means x is between 5 and -5. Let's check the endpoints. When x equals -5. So when x equals -5, so you get -1 to the power of n minus 1. Here we have -5 over 5 to the power of n over n. That's -1, right? So we have -1 to n minus 1, right? That's -1 to the power of n. So you can just add the n's over n. Okay, so simplify it a little bit more. We have -1 to the power of 2n. Really, this means n over -1. So that's always positive 1. So this is just really -1 over n. Okay, -1 over n. So -1 over n looks like this. -1 over x looks like this. Okay. And it's just a flipped harmonic series, right? We know that harmonic 1 over n, it's divergent. -1 over n, if you add all of that, it's going to be just approaching negative infinity. Right, just upside down harmonic series. So we cannot include -5. Let's consider +5. Okay, so let me do that here. Okay, so that will get reduced. Okay, and now we have an alternating series, right? So for an alternating series, it just, the general term here that we need to consider is 1 over n. So is this decreasing? Well, we know what it looks like already. It is decreasing and it's approaching 0. So this is going to converge. So that we include, this we exclude. So that's the interval of convergence.